Analyzing graphs. Before we start, I want everyone to take a moment and complete these two graphing equations by yourself. One's a square root, one's a cube root. So you can press pause on your video and then you can come back and I will fill in my answers. Today we're going to be analyzing graphs. So we're looking at a completed graph. In this case, we're looking at a square root. And we are asked to determine what the function is, the domain, range, and end behavior. So if you understand what the parent function is and you understand the transformations, writing this function should be fairly simple. So again, this is the parent function of the square root. So we have y equals the square root of x. That means the parent graph starts at this location. If you use these 3 points as your benchmark points, it should be easy enough to figure out how this graph is shifting around the coordinate plane. So I can clearly see that we have a point right here. I know they're not marked, but on this graph, it works out perfectly that it's there, here, and then the next point would be here. So it doesn't appear that there is any stretching, shrinking, or reflections. It appears to me that this graph just slid to the left and then it slid down. So in order to fill in the transformation rules on the parent function, I'm going to write this as the square root. Because it went to the left, I'm going to indicate that it's x plus 4. And then because it went down to -5, I'm going to say -5 outside of the square root symbol. So if you're wondering how I came up with those numbers, if we start here and we shift left to -4, and then we shift down to what corresponds with a -5. That's where my numbers come from for my shifts. Obviously, if these points appeared to be stretched, if there was a stretch or there was a shrink or a reflection, you would have to indicate that as well. This one does not have that. From here, we're looking at the domain of the graphed function. So the domain starts at -4 and heads to positive infinity forever. It is a closed point at -4, so we're going to say -4 with a square bracket or a hard bracket to positive infinity. The range starts at -5, never goes below that point, with a square bracket to positive infinity. And as for the end behavior, this graph only heads or only has one end. So end behavior is looking at the graph and how it continues on forever and ever. Well, in this case, we only have one end that is continuing forever. This end here is a end point. It stops right there. So this graph only heads towards positive infinity on the x-axis. It's only heading this way on the x-axis. It never heads towards negative infinity. So the only end behavior that we can write is as x approaches positive infinity, that's moving this way, this end of the graph is facing up or heading up. Of course, it's going very slow, but it is still facing up. So the function is infinity. Okay, number 2 is also a square root function. So if we start with our parent graph at 0, 0, 1, 1, 4, 2, we can see that this graph certainly has a stretch to it. So something happened where this graph appears to be expanded. And I'm going to mark some points. It looks like I have a point right here at -4. My next point is at 1, -2. And then the point after that is at 4, 0. So not only did this graph shift down, but I'm noticing that every point was stretched by a factor of 2. This y value was originally 1. That value doubled. So I can tell right here that this has a multiplier of 2 in order to get it to this size. So I'm going to say that the parent function is the square root of x, oops, forgot the multiplier, 2 times the square root of x. This graph does not shift left or right, but it moves down 4 units, so 2 times the square root of x minus 4. The domain starts here and heads towards positive infinity. So the domain is from 0 to positive infinity. The range is from -4 to positive infinity. And the end behavior, once again, there's only one end to this graph. This graph is heading towards the positive x values. So as x approaches positive infinity, the function is approaching positive infinity. The function is still heading up. Next we have cube root functions, and the parent cube root graph is always going to be the cube root of x. Now let's do number 1 together, and then I'll ask you to do number 2 by yourself. So remember that the parent cube root graph has key points. I'm going to shrink this down to just 3 key points for this because I think that's all you need to know in order to look at the graph. So we're going to say that here's our key points at -1, 1, 0, 0, 1, 1. Of course, you obviously know that there are more points, but these 3 points will help you indicate what's happening to the graph. So we can clearly see this parent function went up. We can see we have a new point here, we have a new point here, and a new point here. So just for the short or the fast version of this, I noticed that this point and this point are 1 unit away. This point is double that distance. So it appears to me that there's a multiplier of 2, or a stretch of 2. It also appears to me that the point at 0 shifted up to 4. So we have a multiplier of 2 and a shift of 4, giving us a function of the cube root, I forgot to write the multiplier again, 2 times the cube root of x plus 4. Now that we're on to cube root functions, this graph heads in both directions. It heads this way and it heads this way forever. So the domain is negative to positive infinity. The range is also negative to positive infinity. The graph heads up and down forever. Besides from the domain and range, this graph has 2 ends. So the end behavior, as x approaches positive infinity, we can see that this end is facing up. So f of x is heading towards positive infinity. However, when we head towards negative infinity on the x-axis, this graph is slowly facing down. The values on the y-axis are slowly getting smaller or heading towards more negative values. So the last end behavior is as x approaches negative infinity, f of x also approaches negative infinity. Number 2 is just a shift to the right and a shift up. So I would like to have everyone try that by yourself. Press pause again on this video, come back and make sure your answer matches mine.